Okay, we'll get into this. You know, here, let me upload this to CCLE. This will just be some list basics, okay? So, you know, we'll be working with a few different data types in Python. But I think it makes sense to start with the list. And then we'll move on to the NP array, which will be very frequently used as well. But lists will appear everywhere. And so let me kind of do this.
What percentage of our grade is quizzes?
Like 10% total. All the quizzes combined are 10% total. So
That's quite a bit.
So I mean, we'll probably, I don't know how many quizzes we'll have, 5, 6. So each quiz is like 1 to 1.5, 2 percentage points total, and then yeah. All right. I think it'll be okay. All right. If we find the quizzes are too scary, you know, well, I'll think about it. But I think it's good. All right. I hope you can download this and open it. But you know, if not, that's all right. Just you can follow along here. It's just a Jupyter notebook. Okay. And then and I'll get this fired up.
There you go. Oh.
And we're just looking at lists. I just stole the list out of the data camp slides, but because I was too lazy to think of a new list. But all right, To make a list, you just use square brackets. Okay, you just enclose whatever it is you're making. You use square brackets. If you there's other things. If you don't use a square bracket, you end up, like if you use the regular parentheses, you end up with a tuple, which, you know, we can talk about that later, but it's not generally our thing. The lists are can contain variables of any type or values of any type, so you can mix strings and floats and integers and booleans and, you know, all of that stuff. So this is mostly for those who are auditing or who aren't enrolled in the class. So one of the prereqs for this class is a programming course in R. And so I'm teaching this class with the assumption that students are familiar with R, and so a lot of these things I'll relate back to R. And, you know, if you're not familiar with R, you know, no worries, okay? So yeah, likewise in R you can have lists and of mixed data types. You can also list nests within lists. All you do is you just put inside the list, you put more square brackets, and you have lists inside lists. Okay, so this is, we'll make that, and we'll make that, and then in IPython, the default behavior is when you type in the name, it prints it out. Okay, so here I've got fam, and it prints out the list. I have fam2, and it prints out the list of lists. Okay. If to subset a list, to refer to values inside the list, we use zero indexing. This is something that is hard to get used to in the beginning if you're coming from R. Most other languages use zero indexing, Python, C, all of those things. But R and MATLAB start counting at 1, like regular people. Okay, but this is what we have. So the first element fam is the one where it's just a flat list, and fam2 is the one where it's lists inside lists. Okay, so fam square bracket 0 will be the first element, string Liz. Okay, fam2 is square bracket 0 returns the first list, because that's the first element, because it's a list of lists. So we'll bring back this, and then so if you want to get, if you're looking at nested lists and you want to get the element inside a list, you have to use a series of square brackets. So here you'd say fam2 square bracket 0 gives you kind of the first list, which is the list that says Liz in 1.73, and then if you do square bracket 0, 0, then it will give you the first element within that list, okay? And so, you could imagine this hierarchy of lists inside lists inside lists, and you can reference them this way. I think this probably feels familiar for us, our users, right? Okay. On the other hand, if you try to reference a value using a negative number, okay, what it does is it counts from the back end, okay? So -1 starts out here, and this is, -1, -2, all the way up through -8, okay? So if we just refer back to this, -1 will give me 1.89, and then if we look at fam2, -1 will give me the last element, which is the list of dad and 1.89. I think this is people's names in the family and their heights in meters, okay? Okay, and again, with just like the nested lists, you can do negative indexing that way. I think that's pretty straightforward. You can open up a blank notebook in Jupyter and type away and try all of this out. Or you can just open the thing. Okay. All right. List slicing is kind of like what it sounds. It's like taking your list and you take a knife, and here, let me copy this just so it appears above our list slicing, so I don't have to keep scrolling back and forth. I haven't made any changes, but there we go. Okay. So when you slice, the first value is kind of the index where you're starting. So because we start counting at 0, 1 is 1.73. Okay, and then the number after the colon, you can kind of think of it as slice at this comma. Okay. So 3, if you say, let's go to the third comma, you're slicing it at Emma, okay? Or you can think of it as not including the element after the colon, okay? So you can think of it as, if we slice this list fam from 1 to 3, we start at element 1, which is here, and we go up to basically the third element, but we're slicing at the comma. So this will return back 1.73 and the string Emma. Okay? And likewise, if you do 1:2, that's only going to return back one element. Okay? And then if you say 1:1, okay, you're starting here, but then you're slicing at the first comma, you're going to get back nothing. You're going to get back an empty list. So it feels like this should give you back 1.73, but it doesn't, okay? If you want, if you're on 1:2, will give you just back one element. So all of these things. So we can run all this, and then, okay, if we do the nested list, it works the same way, okay? From the first element, or the 0th element, 0 indexed element, to the second comma, it will give us back that. All right. If we go back to just the flat list, if you don't specify anything after the colon or anything before the colon, it assumes go all the way to the end or start all the way at the beginning. Okay, so here 2 element indexed at 2 is Emma. So 2: will give me everything from Emma all the way to dad and 1.89. Fam:4 will start at the beginning and go all the way up to the 4th comma, and we'll return back these 4 elements. Okay. And then if you just do a slice with a colon and nothing, this creates a copy of the list. Okay, so this creates a copy of the list. All right. If you're used to R, you were able to just kind of give it an arbitrary vector and say something like elements at 1, 3, and 7, and you wanted to subset a list that way. There's no equivalent ability for that in Python. Okay, Python you got to kind of, when you do a slice, it's basically just using a knife. Okay, you're using a knife to do something. So if you had some kind of list like this, and you wanted to just extract these elements, you have to basically pull out those elements using a small for loop. Okay, so for each element in B, so you're iterating over B, you're going to go that, and then you'll pull out that element, and then and you wrap all of that in square brackets so that the result will be a list. Does that kind of make sense? Okay, so here I've got this list A, which is ABC numbers 3, 4, D, 6, 7, 8. Okay, and it says, you know, let's say I want elements 1, 3, and 7. 1 will be B, 3 is the 3, and the 7 is the 8th element, which is a 7 also. Okay.
Sorry, I left some books and notes here.
Oh, okay. Yeah.
I apologize.
Thought I was in trouble for a second. Okay.
Sorry.
And then, okay, and here we are. Okay, so there you go. C will be a list consisting of each of these things here. Okay. Okay, one thing that is important is that lists are mutable, and if you set two things, if you set another object name equal to you know, an existing list, those things both refer back to the same list. Okay, so basically, so here I've got the list fam, and if I print that out, this is what I have. And here I'm going to say, I'm going to create something called second. This is my second family. Okay, so second is equal to fam, and I am going to replace the 0 indexed element, so that's the first one, Liz, and we're going to call her sister instead. Okay, and if I ask print out this thing that I just renamed to sister, indeed, in the list, the string Liz has changed to sister. Okay, but then if I go back and I say print fam, they are the same thing, and fam itself has also changed. Okay, so this is very different from our users, where every time you set assign something to something else, it creates a copy. That's not the case in Python. With the list, they're both referring to the same list. So second and fam both refer to the same list, and so modifying one or the other, well, there's not two things. They're not two things that are linked. It's the same thing. It's just there's two names now for this thing. Okay. So if you want to have a copy, then you've got to use then you have to create a copy, and you can create a copy using kind of this blank slice method. Okay, so here I'm going to just recreate fam, and here I'll print fam, and over here I will have second is equal to fam square bracket colon square bracket. Okay, so this blank slicing creates a copy, and I'll call that second. So here I rename the first element, okay, index 0 to sister in the copy, and if I print that out, we see that indeed Liz has been renamed sister, whereas, and if I ask print back fam, it has not been changed. Okay. There's also a method here. Maybe I'll do this. I'll call third can be fam.copy. All right. This is equivalent to using the colon slicing. Okay. And I can say print third. Here, let's insert this here. Okay. So here is print third, and then I'll modify Liz's height to 1.65, and then we'll say print this, and then if I print the original fam, we'll see that it's also unaffected. Okay, so when I modify the copy, it's modified, but the original is not. But you can use slicing. So let me just print fam again, okay? And you can use slicing to modify things, okay? So here I will say fam 1:3. So what does 1:3 refer to?
173.
Yeah, 1.73 in Emma, right? I can set this equal to the elements, I'll call this 1.8 and Jenny, okay? And then if I do fam, print fam, here, it changes that, okay? So here, you can use slicing and replace the elements in the slice this way as well. All right. Is this okay? A lot of this stuff is you just got to kind of play with it and get, and it's not muscle memory, but it's just kind of like the vocabulary memory here, okay? And then we've got a bunch of list methods that we'll kind of run through. And these, just like vocabulary, like learning verbs and nouns in Spanish or something, you've got to, you just have to learn these vocabulary terms for list methods, okay? So we've already seen list copy, okay? Or you can use the square bracket with the empty slice, and that creates this, okay? We have list append, okay? This will just tack on an item at the end of the list, okay? So here, if fam is this list, if I say append me in quotes and I print that out, this is what I get, okay? So the result is the original list plus the string me, okay? You can also append lists using the addition operator. Okay, you can just take another list and tack that on. But here you have to capture the output. So here, fam.append, you don't have to say give me the. So notice here I don't have to say fam equals fam.append me. Okay. I just say fam.append me, and it modifies fam, okay? Over here, if I do fam plus 1.8, okay, this does not directly modify fam. If I want the family list to be modified, I have to say family, or fam, is equal to fam plus that thing, right? So the net result is the same, but over here you have to capture the result of this change, whereas over here, using the method directly changes the object. Okay, is that distinction okay with you guys? Yes, question.
You have in your notes like a shallow copy. I was wondering what the difference is between a shallow copy versus a non-shallow.
Oh man, you're asking me these tough questions. I copied directly just from the manual page in Python. Let me see. We'll look up what is Python shallow copy. All right. A shallow copy constructs a new compound object and then inserts references. Oh, a deep copy and then recursively inserts.
If you design it just like the name itself, then like the changes you make to the new one will apply to the old variable as well, I think. But like
Okay. Two problems exist with deep copy operations that don't exist. Recursive objects may cause a recursive loop because deep copy objects copy everything in the copy. All right. I don't know. I'll play around with it some, and I'll try to give you an answer later. Okay. I'm thinking if you have like lists nested in lists, and yeah, let me play and see if I can break something and figure out where things go different. Okay, but yeah, you copy. I just copied and pasted directly from the help page on lists, and without knowing fully what shallow copy is here. Okay, all right. If you want to insert something into it, okay, you can say, so here's my original list, fam, and I want to say insert into index 4 Joe, okay? So index 4 is going to be right here at mom, okay? So it's going to index right here. So you can kind of think of it as after comma 4, okay, it's going to put that there. If you try to insert multiple things using a list, okay, then it inserts an actual list there rather than these two things. And then, so if you try saying, well, okay, let's try to insert this with, I want to insert Joe and the number 2, then it kicks back an error. You can only insert kind of one thing at a time using the insert element. So, so there's a few options for this, or not options, but just you can do extend. Okay, extend is kind of like we'll extend the list here. Or you can kind of use this slicing thing. And so here, 4:4, again, this doesn't actually return anything, but it tells us to try to insert this thing into that position here. So if I do using the slice operator, where there's currently nothing there, okay, and I use fam slice from the 4th element to the 4th comma, which is this spot right here, right before mom, I can put in Joe and 2, and that successfully gets inserted into that position there. So these are kind of like, I don't know, little workaround tricks. All right, so again, learn these list methods. We've got, and just, again, the best way is just to kind of play around with these things, okay? Oh, and notice, so all of these things with the list, it says list.copy. You don't actually write list.copy. Whatever the list is called, so in this case, the list is called fam, so you use fam.append, okay? So anytime you have a named list, you're just going to use the name of that list there. It's not actually list.this, it's the name times that dot the thing. Okay, over here we've got remove, pop, and clear. These take things out of the list, okay? So here, Liz did something bad, you're going to remove her. So you do fam.remove, and you just put in whatever it is that you're going to remove, okay? And here, when you print that out, we see that Liz has been removed, okay? Here we've got the list fam, and pop will remove by default the last element in the list, okay? Pop will also return this value. So it's not, I don't actually have it here, but if I have, so if I say j is equal to fam.pop, I can do something with that thing that I just popped out, okay? So pop kicks it out of the list, so it modifies the list, but the thing that you just took out is also returned by the function here. So maybe, yeah, we'll just do that. Okay. So when I run this, it pops out 1.89, and the resulting list is here. Okay. I'll do J is, and if you specify an index to pop, it will pop the element at that index. Okay. So again, the original list is Liz 1.73, Emma 1.68. So pop 2 will remove the item at index 2, which in this case is Emma. Okay. So what we see is, here's the thing. We're going to pop the second element, or element at index 2, which is Emma, and then if we print back fam has been modified. Okay. Okay, and then fam.clear just clears everything out of the list. Boom, gone. Okay, makes a empty thing. All right, we also have kind of these things to help us find or locate items in the list or count things in the list. Okay, so you can just say what's the index for the element called Emma. Okay, and that's at index 2. So this is kind of like which in R. You have R, you know, which item is this? It's kind of like that. Okay, but it's just giving me back the index. All right, and then count. You just say count how many times this item appears in the list. So this is not like the best list. I should probably have a better list. Like, we'll call this alpha. No, we'll call this letters. And this will be a list of A and B and C and A and A. Okay, and then whoops, and then here I'm going to do letters.count A, and we'll say A has appeared 3 times. Okay, yes, question.
Does it only count first level? Like if you had a list that list inside a list had an A in it, would it count that as well or no?
I think it only counts at the first level. Yeah, we'll just double check. Okay. All of these things are good questions, and we'll mess around with it. All of these things. All right. So we got fam2. All right. Let's do fam2 dot count. I'm pretty sure if I say Liz, it will just tell me back there's nothing. Yeah. Okay. But if I do print fam2.count, how many times does this thing appear, which is, now this is like, well, of course that's in there, right? So it's not as exciting, but there you go, okay? So A appears 3 times in this list. Liz, I guess the string, the naked string Liz, does not appear anywhere inside the list of lists, but the list here appears like that. Okay. Also useful is a sort. Okay. Sort, you can sort things, reverse the items in the list. Okay, if you try to so here reverse just puts them in opposite order. So Liz is now at the end, and then Dad's height is at the beginning. If you try to sort it, it says I don't know how to sort numbers and strings together. Kicks back an error. Whereas if you just have numbers or if you just have strings only, you can sort them, and it'll sort in alphabetical order or numeric order. You can do reverse equals true. Okay. Trying to think if there's anything else that needs to be done. Oh, I guess going back to the slicing, you can have negative slices also. Like you can use just like you have negative numbers to refer to the items at the end of the list. You can use negative numbers for things at the end of the slice. So let me just, oops, here, whoops. So I can do from negative 5 to, here, wait, let me just print fam first, and then we'll print from fam negative 5 to negative 2. Oh, shoot, I just modified fam and cleared it out, so. Okay, so here, so here's fam, and then negative 5. You count back the commas 1, 2, 3, 4, 5. Okay, and you're going to start right here at 1.68, or I mean 1, 2, 3, 4, 5 to negative 2, going up to the kind of the second comma. So as far as the slicing goes, using a negative slice there. Okay. Are there any questions on list methods, things like that? I guess I can, well, we got 5 minutes left. We can do some string methods. Whoops. Okay, so we'll name will be here. So you can have upper, and that brings everything up. You got name dot capitalize, name dot lower. I got to print all of these out. Sorry. I guess name dot lower is not really going to make a difference here. Okay. So capitalize just capitalizes the first letter in the string. All right, you've got name dot count. How many times does the letter E appear? What else do we have? Oops. Name dot ends with K. That's going to return false, whereas name dot ends with N is true, and there's also going to be starts with, or so you got name dot ends with name dot starts with capital M will be false, right? Okay. Oh, all right. I'll call this name 2. So you might have so we have this, and you have strip, okay, and that removes extra white space from the beginning and end. Wait, let me go back back over here. So we have capitalize, which does the first letter, and we got name dot title case. Oh, I'm sorry, no, not title. It's just not title case, it's title, okay? And that will, when it recognizes a white space, it will capitalize the letter after that, okay? What else can I do? Oh, string split. This is like super useful. Okay, name dot split. Okay, and it will find the white space, and it will return back a list after it has split it using using kind of the white space as a thing. Or I mean, you can specify other delimiters, but the default is white space. So it's, if you have like if you have a bunch of commas to separate something. So if we've got nums is num string will be 2, 3, 2, 3, 4, 7, 8. Okay, you can do num. So if you do num string dot split, this is not going to do anything. But if you do num string dot split using comma, then it splits them out into the list. Okay, so split, super super great. And then you can do other things like, all right, so name, sorry, I know we're gonna run out of time here. You can do is alpha name, whoops, what did I do? Oh, I'm sorry, no, see, I'm getting mixed up here. Okay. So yeah, there's a space in alpha, but
What does alpha do?
is alpha is if it's only
Oh, if it's all letters?
yeah, if it's all letters. Okay. That will return true. Okay, I'll clean this up a little bit, and I'll post the cleaned up version of this.
It was like